Hello. In this activity, we're going to make a completely circular path. Here, particles with the same mass, velocity, and charge will be projected from a source inside a magnetic field. Let's drag the flux density slider to a relative value of +1. This time, only a single circle with a dot is used to represent the lines of force that are coming out of the plane of the diagram as before. Let's click play to project a stream of charged particles into the magnetic field with the relative values of charge equal 2, velocity equal 3, and mass equal 1. Note that these values of B, Q, V, and M just keep the particles from leaving the magnetic field and they form a complete circle. Let's select force to show the forces that act on the individual particles. Let's click stop to stop the particles. The constant force of the particles perpendicular to their path provides the centripetal force needed to make them follow the circular path. The force F on a charge Q moving with a velocity v in a magnetic field of flux density B is given by F equal to BQV, and the centripetal force needed to keep a particle of mass m traveling in a circular path of radius r with a velocity v is given by F is equal to mv squared divided by r, which is the centripetal force. Here, the magnetic force provides this. Therefore, in this experiment, the two forces are equal. So, BQV is equal to mv squared divided by r. So, if B is increased, while QV and M are unchanged, the force available to produce a centripetal force and acceleration increases, and the path radius should be reduced.